Let's go through the correct answers to these questions. This one, experiment 1, was a between subjects design because one group of 3 participants listened to classical music, one group of 3 participants listened to rock music. So a separate group of people listened to classical and a separate group listened to rock. And each person was only tested once. Each person was tested either under classical or under rock, but not both. So that was between subjects design. It's also not matched because we don't have any matched pairs in here. Experiment 2 was also between subjects design because we have a separate group of 3 people listening to classical music right here, persons 1, 3, and 5, and a separate group of people listening to rock music, persons 2, 4, and 6. So we have a classical group and a rock group. And also, before we assigned each person to the classical group or the rock group, we formed these matched pairs. We grouped these 2 people together who both had an IQ of 102. We grouped these 2 people who had an IQ of 104. And we grouped these 2 people who had an IQ of 105. And then one person from this matched pair went to classical condition. The other person went to the rock condition. One person in this matched pair went to classical, and one person from this matched pair went to rock. And the same thing happened for the third pair. So this would be called a between subjects design, but it would also be a between subjects design with matched pairs. Over here we were just doing pure random assignment. The assignment of people to classical or rock was purely random over here. So this was pure random assignment. But over here it was matched random assignment, where we form matched pairs and then we randomly assign the people inside each matched pair. This one down here, experiment 3, was within subjects design because we didn't have a classical group and a rock group. We just had one group of participants. And this one group of 3 people went through both conditions. Person 1 had their memory tested while listening to classical music, and at a different time had memory tested while listening to rock music. Person 2 was also tested one time while listening to classical music and one time while listening to rock music. So each person was tested at 2 separate times, and one time with one music and the other time with the other music. This would be called the within subjects design. Also, in a between subjects design, there's no counterbalancing because each person is tested one time only. So this is no, and this is no counterbalancing. Each person is tested one time only in a between subjects design, either under classical music or under rock music in this case, but not under both classical and rock music. But in a within subjects design, each person is tested twice, one time with classical and one time with rock. So in this case, we do need counterbalancing. We need for half of the participants to be tested with classical first and with rock second, and we need the other half to be tested with rock first and classical second, which is the opposite order. So we do need counterbalancing in a within subjects design. So that's why for the between subjects design it was no and no, but for the within subjects design it was yes. In a between subjects design, each person is randomly assigned to one condition. Each person is randomly assigned to the classical condition, where they listen to classical music, or to the rock condition where they listen to rock music. That's true here in experiment 1 and in experiment 2, because they're both between subjects designs. But in a within subjects design, you're not assigned to one condition or the other. You go through both conditions. So in this case, you're assigned to a specific order of conditions, meaning you're randomly assigned. Each person is randomly assigned to either listen to classical and then rock, or to listen to rock first and then classical. So in the within subjects design, each person is randomly assigned to the classical rock order or to the rock classical order. This question right here asks, is it possible that the difference in recall in this matched pairs design was caused by one group of participants having different IQs than the other group of 3 participants? Well, if the classical group and the rock group perform differently at the memory task, it can't be because of IQ, because the classical group has IQs of 102, 104, and 105, and the rock group also has IQs of 102, 104, and 105. So the classical and rock groups are equal in IQ. So if the classical group does better than the rock group, it can't be because of an IQ difference. The whole point of matching the participants was so that the classical and rock groups would be equal in IQ. Because if when the 2 groups are equal in IQ, then we know that that the difference in performance between the groups can't be because of IQ. So IQ was ruled out as an alternative explanation, and we're more confident that the classical music is what had the effect. That's the point of the matching. Here's the next page. Here we're doing counterbalancing with the within subjects design, but it's not fully counterbalanced because 2 people are getting this order of pH and then RT, but only one person is getting pH and then I'm sorry. 2 people are getting pH at time 1 and RT at time 2. So 2 people are getting the pH and then RT order, but only one person is getting RT at time 1 followed by pH at time 2. So only one person is assigned to the RT and then pH order. So in this case, it's not fully counterbalanced because we don't have an equal number of people assigned to the 2 orders. So what questions did I ask you in here? Well, I told you to make up some ratings, some taste ratings for Pizza Hut and Round Table, and I told you to fill them in here. So I made up 4, 3, 2, 3, 2, 4 as my ratings. And I told you to subtract 1 from all of the ratings at time 2, which are here, here, and here, because we're saying that at time 2 people are starting to get fatigued, so their rating drops by 1. The idea is that this rating right here is what they would have had without fatigue, but since they are fatigued, it drops down to this. So I filled in all of these numbers. I filled in 4, 3, 2, and I filled in 3, 2, 4, and I subtracted all of the time 2 ratings by 1. And then this question says, which condition came out ahead in the experiment? Well, what all this is asking is which condition came out ahead in the taste test. Which type of pizza did the participants like more? To do that, I have to average the 3 taste ratings that were recorded for Pizza Hut, which are 3, 4, 3, and 1. These are the final taste ratings. 4 plus 3 plus 1 is 8. 8 divided by 3 is 2.67. That's the average for Pizza Hut. The taste ratings for Round Table were 2, 1, 4. If I add those, they add up to 7. 7 divided by 3 is 2.33. So it looks like people liked Pizza Hut more than Round Table because Pizza Hut had the higher taste average. So I didn't mean to put 2.67 here. I meant to put PH or Pizza Hut as the answer right here because they came out ahead. Now this is saying was the results affected by fatigue. What I wanted you to do for this part of the assignment is to imagine that each person's taste rating has a level of fatigue. So, and if it's a taste rating at time 1, it has a fatigue of 0 because there's no fatigue. and if it's a taste rating at time 2, it has a fatigue level of 1, because there is some fatigue. So, so every taste rating had a certain level of fatigue, which was 1 or 0. And what we did was we calculated the averages of the fatigue scores. Basically, what the fatigue scores were just the numbers that we subtracted by. At time 1, we subtracted all of the ratings by 0, which means they didn't change. So this was a fatigue score of 0, fatigue score of 0, fatigue score of 1 for Pizza Hut, 0, 0, 1. And I put them over here for Pizza Hut, 0, 0, 1. They're just the numbers that we subtracted by. And then for Roundtable, the fatigue scores were 1, 1, 0, right here. They're just the numbers that we subtracted by. So what I did was I calculated the average fatigue score for Pizza Hut by adding them up and dividing by 3, and it came out to 0.33. I took the 3 fatigue scores from Roundtable, which were 1, 1, 0, added them and divided by 3, and I got 0.67. So I told you that the fatigue scores are just the numbers that we subtracted by. And I averaged them over here. And if the two fatigue averages came out to a different number, it means that the results were affected by fatigue. So it's a yes. Now, which condition was affected the most by fatigue? It was Roundtable, because Roundtable had the higher fatigue average, so it was affected the most. 0.67 is higher than 0.33. Which condition had the advantage? Well, whichever condition had a lower amount of fatigue had the advantage. So pH had the lower fatigue average, so since it had the lower fatigue average, it had the advantage. And how can you tell that the experiment was not fully counterbalanced? Well, it was because the number of people assigned to the two orders was not equal. We had 2 people assigned to this order of pH followed by RT, and only 1 person assigned to this order of RT followed by pH. So it wasn't fully counterbalanced. You can also tell that it wasn't fully counterbalanced because the amount of fatigue wasn't equal in the 2 conditions. These 2 numbers weren't the same. If it was fully counterbalanced, it should have made it so that the fatigue was equal in the 2 conditions, or across the 2 conditions, because the purpose of counterbalancing is to make the fatigue equal across the 2 conditions. What do we have? This was the same type of worksheet over again, except now we have 2 people assigned to this order and 2 people assigned to this order, which means that it is fully counterbalanced. There's an equal number of people in the 2 orders. It's 2 people and 2 people. So I just made up some ratings again, some taste ratings. The ratings I made up were 4, 3, 3, 2, 5, 2, 4, 3. And once again, I subtracted all of the ratings at time 1 by 0, which doesn't change them. And I subtracted all of the ratings at time 2 by 1, which brought them down by 1. And my answers that I got after subtracting were the final taste ratings, or the actual ratings that people gave. So in order to find out which condition came out ahead, I have to average the 4 taste ratings for Pizza Hut. I have to average the 4 taste ratings for Roundtable. So 4 plus 3 plus 2 plus 1 is 10. 10 divided by 4 is 2.5. That's the average for Pizza Hut. For Roundtable, 4 plus 1 plus 4 plus 3 is 12. 12 divided by 4 is 3. So the average taste rating for Roundtable was 3, which is higher than the average taste rating for Pizza Hut, which was 2.5. So Round Table came out ahead in the taste test. To find out whether the results were affected by fatigue, I have to take these numbers that we subtracted by, which were the fatigue scores, the levels of fatigue, and average those. So for Pizza Hut, we have fatigue scores of 0, 0, 1, 1. I put those over here. For Round Table, we had fatigue scores of 1, 1, 0, 0. I put those over here. The average fatigue for Pizza Hut was 0.5. The average fatigue for Round Table was also 0.5. Since the two fatigue averages came out to the same number, the results were not affected by fatigue. The counterbalancing did its job. So, which condition was affected the most by fatigue? Neither, because they were affected equally by fatigue. The two fatigue averages came out to the same number. Which condition had the advantage? Well, once again, since the two conditions had the same amount of fatigue right here, 0.5 and 0.5, neither condition had the advantage. How can you tell the experiment was fully counterbalanced? An equal number of people were assigned to the two orders. It was 2 and 2. So now it is fully counterbalanced. Also, we can tell that it was fully counterbalanced because the fatigue averages came out to the same number this time. That's another way to know that it was fully counterbalanced. And what kept the results from being affected by fatigue? What made it so that the two fatigue averages came out to the same number? Well, it's just because the experiment was fully counterbalanced. We had the same number of people assigned to the two orders. It was 2 and 2 instead of 2 and 1 like it was the first time. Now, here we had counterbalancing again, but this time it was a different type called reverse counterbalancing, which means each person gets one order and then the opposite order. I was saying that fatigue is linear, meaning it goes from 0, 1, 2 to 3. It goes up in a straight line. So what I wanted you to do was subtract first I wanted you to fill in ratings for all 4 columns. So I filled in 4, 4, 6, 7, 6, 7, 5, 4, these ratings and these ratings. I subtracted all of the time 1 ratings by 0 right here. I subtracted all of the time 2 ratings by 1 right here, all of the time 3 ratings by 2, and all of the time 4 ratings by 3. And I got these final ratings over here as my answers. What I did next was I took for each person, I took the 2 Pizza Hut ratings and I averaged them, and I took the 2 Round Table ratings and averaged them. So for person 1, I took 4 and 1, which are the 2 Pizza Hut ratings. I averaged them, so 4 plus 1 is 5. 5 divided by 2 is 2.5. That gave me the person's Pizza Hut average. I took the 2 Round Table ratings, which were 5 and 4. 5 plus 4 is 9. 9 divided by 2 is 4.5. I did that for each person. For person 2, it would have been Pizza Hut was 4 plus 1 is 5. Divided by 2 is 2.5, and 6 plus 5 is 11. Divided by 2 is 5.5. After I did all of these, I added them and divided by 4, and I got the taste ratings. Round Table had the higher taste average because it came out to 4. That's higher than 3.5. To find out if the results were affected by fatigue, I had to calculate the average of the fatigue levels. So what I did was I said Pizza Hut had a fatigue of 0 at time 1 and 3 at time 4. So Pizza Hut had a fatigue of 0 at time 1 and 3 at time 4. I took those two numbers, added them, divided by 2, and I got 1.5. I took the 2 Round Table fatigue levels, which were 1 and 2, added them and divided by 2 to get an average, and the average is 1.5. So the fatigue averages were equal, which means that the results were not affected by fatigue. Neither condition was affected more by fatigue because the 2 fatigue averages came out to the same number. Neither had the advantage because the fatigue averages came out to the same number. It was fully counterbalanced because each order was used the same number of times. Each person got both orders, the first order and then the opposite order. So the order of pH followed by RT was used 4 times because all 4 people had that order, and the RT followed by pH order right here was also used 4 times. So order 1, the AB order, was used 4 times. The other order, which was BA, was also used 4 times. So the experiment was fully counterbalanced. Since it was fully counterbalanced, the fatigue averages came out to the same number. What kept the results from being affected by fatigue? Well, it was just fully counterbalanced. The counterbalancing did its job and made the fatigue averages equal. The next one was fatigue is not linear. It was the same thing over again, except now the fatigue jumps. It doesn't go up in a straight line. So instead of being 1, 0, 1, 2, 3, it's 0, 1, 3, 3. And now I subtracted by zeros here, by 1s here, by 3s here, and by 3s here. I subtracted by all of these fatigue levels for each column. So I got these answers, these answers, these answers, and these answers. I did the same averaging that I did before. Pizza Hut came out ahead because it had the higher taste average. 3.75 is higher than 3.5. The results were affected by fatigue because I took the 2 Pizza Hut fatigue levels, which were 0 and 3, and got the average as 1.5. I took the 2 Round Table fatigue levels, which were 1 and 3, averaged them, and it came out to 2. So it looks like Round Table did have more fatigue than Pizza Hut. So the results were affected by fatigue. Round Table had the higher fatigue average. 2 is higher than 1.5. Which condition had the advantage? Pizza Hut had the advantage because it had the lower fatigue average. When you have the condition, since it had lower fatigue, its taste ratings didn't suffer as much because of fatigue. So Pizza Hut had the advantage in the taste test. Also, this activity shows that reverse counterbalancing only works when fatigue is, when it's linear, because when it was linear, when it was 0, 1, 2, 3, the fatigue averages did come out to the same number. The counterbalancing worked. But now that it's not linear, the fatigue averages don't come out to the same number, and the counterbalancing doesn't work anymore. So it only works when it's linear. Reverse counterbalancing only works when it's linear.